Hey everyone, and welcome. Today we're going to tackle something that's a real headache for a lot of us, managing just mountains of scattered files. We're going to see how we can turn that chaos into a super smooth, automated workflow. We'll be digging into two incredibly powerful command line tools that, when you put them together, can seriously save you hours of manual work. So here's what we're going to cover. First, we'll talk about the challenge of managing files in the first place. Then, we'll see how to use find to locate exactly what we need. After that, we'll bring in xargs to actually do stuff with those files. And then, this is the really cool part, we'll unlock a huge speed boost with parallel processing and finish up with some essential best practices. All right, let's jump right in. Okay, first step, the file management challenge. Let's set the stage and talk about the actual problem we're all trying to solve here. So just picture this for a second. You spend all this time carefully crafting your data into these beautiful, structured, relational databases where everything is just so easy to query. It's clean, it's organized, everything has its place. But then you look over at your file system. Is it quite as neat and tidy? Probably not, right? And really, this is the heart of the problem. You know, in a database, everything's structured. The records are consistent, they're simple to query. But on a file system, we're often dealing with just tons of scattered files. They're way harder to manage, their names are all over the place, and they're buried in these unpredictable directory structures. It's a mess. So how do we start to fix this? Well, that brings us to our second section, and the first part of our solution, finding those needles in the haystack with a fantastic tool called Find. And that's the big question, isn't it? When you need to track down, say, all the FASTQ files from one particular experiment, or maybe all the temp files that are bigger than 10 megs, how do you even start? You're not going to click through folder after folder manually, right? There has to be a better way. And the answer, of course, is Find. You should really think of it as your file system's own private detective. It's a command line tool that will just dive deep into all your directories, searching recursively for any file or folder that matches the exact rules you give it. Okay, let's look at a super simple example. Now, this command might seem basic, but it's doing a ton of work for you. Find dot. That just means start searching right here in the current directory. Then, name tells it we're looking for a specific name pattern. And that star is a wildcard. So star.fastq is going to match any file that ends with the .fastq extension. So with one simple line, you're telling it to go find every single fastq file here and in every subdirectory below. Pretty cool. But the real magic of Find is just how flexible it is. It's not just about file names. As you can see, you can search by type. So you can tell it, only give me files or only give me directories. You can filter by size, like finding everything over 10 megabytes. You can even search by time, like grabbing anything modified in just the last week. And the best part? You can chain all these together to build incredibly specific, powerful searches. Now, finding files is great, but it's usually just step one. Most of the time, we want to do something with that list of files. And that brings us perfectly to section 3, taking action on files. So let's imagine a real-world scenario. Let's say our find command just found hundreds of temporary log files that are just cluttering up our whole project. How do we get rid of all of them in one clean, efficient shot? Well, this slide shows two different ways to do it. On the left, you've got find's built-in -xx option. It works, but it's super inefficient. It runs the delete command, rm, once for every single file it finds. But on the right, you've got a much, much smarter way, piping the results to xargs. What xargs does is it bundles up that whole file list and runs rm as few times as possible. Honestly, it's the difference between making 100 separate phone calls and just sending one group text. Way more efficient. So let's break down exactly how this pipeline works. It's actually pretty elegant. First, find does its job and generates a long stream of file paths. Then that little pipe symbol, it acts like a tube, just feeding that stream directly to the next command in line. And finally, xargs is waiting at the other end to catch that stream and pass all those file paths as arguments to whatever command you want to run. But wait, there's more. The efficiency of xargs goes even deeper. It has this kind of hidden superpower that's amazing for processing huge amounts of data. And that brings us to section 4, unlocking parallel processing. Okay, let's raise the stakes a bit. Your find by xargs pipeline is working great, but the task itself, maybe it's a complex script to convert data, is kind of slow. So when you're running it on thousands and thousands of files, the total time could stretch into hours, maybe even days. That's a huge bottleneck. This is where the real magic happens. By adding just one simple little flag, -p4, we're telling xargs to launch up to 4 processes at the exact same time. So instead of grinding through your files one by one, you're now using multiple CPU cores to get the job done in parallel. Each one is just chugging away on a different batch of files. And the impact on your total runtime can be absolutely staggering. I mean, this chart says it all. A task that might have taken, say, 100 minutes to run one by one could potentially finish in just 25 minutes using 4 parallel processes. This is literally how you can turn a job that would have taken all day into something you can knock out before you even finish your coffee. But, and this is a really crucial pro tip, this isn't some magic bullet you should use for every single task. There's a little bit of overhead cost involved in just setting up and managing all these parallel processes. So for really quick and simple jobs, going parallel might actually be a tiny bit slower. This technique really shines when you're dealing with a ton of files, or when the task you're running takes a good chunk of time for each file. And that brings us to our final section, power and practice. This is where we're going to balance the incredible things these tools can do with some of the real-world tricky parts you need to watch out for. You know, this quote just sums it up perfectly. With all the great power you get from these advanced workflows comes a bit of responsibility to understand how they work under the hood. The more complex your pipelines get, the more careful and deliberate you need to be. So let's wrap up with the key takeaways. Number 1, use find to be a surgeon, locating exactly the files you need. 2, pipe that list over to xargs to process them all efficiently in a batch. For those really big jobs, remember to add the P flag to parallelize everything and get those huge speed gains. And also, just be aware of tricky situations, like file names that have spaces in them. There are ways to handle that. But the most important thing, and I really can't stress this enough, always test your big scary commands on a small, safe copy of your files before you unleash them on your critical data. And there you have it, your deep dive into advanced file automation with find and xargs. So now I have a question for you. Thinking about your own projects, what's the first repetitive, annoying file task that you're going to go and automate? The possibilities are really endless. If you found this useful, please go ahead and hit that like button, share it with your colleagues, and definitely subscribe for more deep dives into the tools that make our lives easier. Thanks so much for watching.